Let's dive into the most common safety concerns for welding and cutting. Up next is a description of each hazard along with the precautions, personal protective gear, and safe practices that you can use to prevent incidents and injuries. First up is electricity, which is probably no surprise because arc welding involves electricity. And electricity is dangerous because you can get shocked, so it's serious business. Now, there are two main areas of shock potential in an electric welding or cutting system. The first is, yep, you guessed it, where you plug the machine in to get power. This is the primary side of the system, where power comes into the machine. This power is high voltage and low current. Generally, the higher the voltage, the greater the potential for shock. This is the machine output side, which is also called the secondary. And it's where the power is delivered to the welding circuit. To avoid shocks, don't touch live electrodes or electrical parts. Insulate yourself from the work and always wear dry, insulating gloves. It's a good idea to have a second pair of gloves in case you sweat through the first pair. And I can tell you from experience that if you feel a little tingle, you're overdue for some dry gloves. You should also inspect your equipment. Make sure that you have a good work connection and repair or replace any damaged cables. Keep guards and covers in place when you're operating the equipment. Hey, they're there for a reason, right? And always disconnect power before servicing any of your equipment. And that doesn't mean just flip the power switch on your welder. You have to actually unplug it from the wall or switch off the circuit breaker, or there's still power coming into your primary switch. The next common hazard involves bright light and radiation. Welding produces bright, visible light that we can see. And arc welding also produces infrared and ultraviolet radiation. These arc rays can burn your eyes and your skin, so you have to cover up. Eye protection for welding always begins with safety glasses. And those safety glasses should meet ANSI Z87.1 specification for impact resistance, side shield protection, optical clarity, and UV protection. And from there, eye protection for welding and cutting really depends on the application. Shaded filters for welding and cutting block the harmful light that's generated during the process. And shade darkness is indicated by a numbering system up to about 14. And the higher the number, the darker the shade. Cutting glasses, goggles, and face shields that are used with oxy-fuel typically require a lighter shade than arc welding because the light is less intense and the flame doesn't produce infrared or ultraviolet radiation. So a number 5 shade is common for oxy-fuel welding or cutting when you need to see past the bright light. And it's not mandatory to cover your entire face because the exposed skin around the mask won't get sunburned. Although a full face shield does block more heat than a pair of tinted safety glasses. Now, arc welding is a different story. And arc welding requires a full face mask for maximum protection from arc rays. Shades for arc welding are typically darker than what's required for oxy-fuel. Number 9, number 10, and number 11 shades are common, depending on your process and the welding current or amperage that's being used. The higher the amperage, the higher the shade is required to block the light. So how do you know what shade you need without going through trial and error and ending up seeing bright spots? Well, that depends on what you're doing and how much. Oxy-fuel is fairly straightforward. You need a number 5 shade. But arc welding processes typically require a shade number 9 through as high as a number 14. Auto darkening helmets are a huge benefit for welding. The lens lightens in shade to improve visibility when you're not welding and automatically darkens when you strike an arc. This eliminates the need to constantly raise and lower your hood between welds, and it makes it a lot easier for beginners who often struggle with a fixed shade hood. Many auto darkening hoods also have lighter shade settings for cutting and grinding, so the same helmet works for all applications. And I wear my safety glasses right underneath my welding hood because I've had sparks bounce around inside my helmet more than once, so it's nice to have a little extra protection in there. Welding curtains or screens are also helpful protection in the shop. These are typically used to shield the welding zone in order to block the intense light from affecting others that are nearby. If you're welding where others can see the arc, use a welding curtain to shield them from the bright lights. These are typically designed to prevent accidental arc flash, and they're not normally dark enough to watch the arc for long periods of time, so I wouldn't try that. I have seen welding screens that were much darker, but they're not all that common. To protect yourself from bright lights and radiation from welding, you need to shield your eyes and cover any exposed skin. Always wear safety glasses that meet the ANSI Z87.1 requirements. Then use the appropriate goggles, face shield, or mask with a properly shaded filter based on the process you're doing and the intensity level that you're operating at. Cover all your exposed skin in fire-resistant or FR-rated material. Wear a cap to deflect sparks and spatter, and use ear protection to keep sparks out. Aside from bright light and radiation, welding and cutting involve heat. Lots of heat, like enough heat to melt steel. So materials in the welding area could be and are likely to be very hot. At the same time, welding and cutting generate sparks and flames, and you need to protect yourself from all of these. When you're welding and cutting, you're literally playing with fire. So it's important to wear fire-resistant clothing for maximum personal protection. Leather, cotton, or wool are good natural choices because they are flame-resistant. Cotton can be treated to improve its flame resistance, which is commonly used for the lightweight welding jackets you might see out there. Leather undoubtedly provides the best protection, but it's hot and heavy to wear. As a result, many welders opt for treated cotton or specially made flame-resistant materials, using leather only for extreme conditions where maximum protection is needed. Your personal protective gear, or PPE for welding, should include a welding shirt, a jacket or sleeves that cover your skin. Remember, any exposed skin will burn quickly when welding, as though you spent too much time in the sun. Jeans, cotton pants, or dedicated welding pants are required to protect your legs. And they should be in good condition, which means no rips, no tears, no frays, because they may not keep sparks out and frays can more easily catch fire. Leather gloves, leather work boots, and a cap or beanie may also be needed depending on just how many sparks you're throwing. Do not wear man-made plasticized materials for welding and cutting. So no nylon, no polyester, no rayon, and other materials that are not flame resistant because they might melt, ignite, or even cause severe burns. There are lots of choices for hand protection. Welding gloves have traditionally been made from leather of differing thicknesses, depending on the process they're intended for. Fire-resistant gloves, such as Carbonex, are also used with leather to improve breathability, flexibility, and reduce overall weight. Gloves can be made from 100% FR materials, but those are typically just for handling hot metal and not so much for welding because they don't provide the same electrical insulation that leather would. TIG gloves are normally made from the softest leather. They're the thinnest type of glove and usually the least durable. Delicate TIG work at low currents requires little heat insulation but demands high dexterity for accuracy and precision. To preserve your TIG gloves, only use them for welding. Use different, heavier gloves that are more durable for metal preparation, sanding, or grinding, and you'll thank me later. TIG-MIG combo gloves are thicker than those recommended only for TIG. These gloves trade in thin flexibility for a little bit of extra insulation, durability, and heat resistance for higher amperage welding. They're sometimes on the thin side for heavy-duty MIG or flux core welding, but they do well for low-amp wire feed processes. MIG stick combo gloves are the thickest and most durable glove, usually designed to handle the high heat of stick, pulse, or spray transfer MIG and flux core welding. They're the least flexible type of glove, but they offer the most protection and usually last the longest time. As a tip, you can mix and match glove types depending on what you need and where the heat is. Many welders use a thin glove on their torch hand, which is away from the heat, and a thicker glove on the hand that's closer to the heat. As a tip and a warning, do not use mechanics gloves for welding or cutting unless they are specifically FR rated. Many mechanics gloves that are sold out there have leather palms with nylon backing that is not flame resistant. That means they will not stop sparks and could melt or ignite and cause serious burns on your hands. So do not weld in mechanics gloves. For extra hand protection, consider using a heat shield over your welding gloves. These can prevent burns and blistering from a hot welding arc or when resting your hand on some hot work trying to improve your stability. MIG and flux core designs are normally leather construction with an aluminized heat shield to block and dissipate the heat, and they use palm straps to hold the shield in place. TIG designs focus on insulating the resting part of the hand, usually the pinky and sometimes along the outer palm of the side of the hand. This allows you to prop your hand for support and be steadier with the torch. But the work can get hot, so extra insulation can keep you welding longer and keep your hand a little bit cooler. Now, in addition to protecting your hands, you need to protect your feet. Welding boots are an important part of foot protection, especially if you weld professionally or all day. Boots should be made of leather and FR materials, right? So they block sparks and they're non-flammable. Some work boots have nylon facets and should not be used for welding because basically if a spark hits them, they're gonna melt. Better boots use non-flammable stitching like Kevlar, so they hold up better in the shop. And many welders prefer boots with no laces because they keep sparks out better than laces, which can trap sparks or hot metal and increase the chance of burning your foot. Steel or safety toes are options, and metatarsal coverage might be required depending on the job site. Boot soles should be slip, heat, and oil resistant for maximum stability and protection. And remember, boots should keep sparks out, so never tuck your pants into your boots. Always wear boot cut pants or jeans that fit over the boots, covering the opening and helping to block sparks or keep hot materials from falling in and giving you a hot foot. To avoid burns from hot metals and hot parts, assume everything in the weld area is hot, because it could be. Heat from welding can travel through parts, tables, clamps, and other tools in contact with the work. Metal is conductive, and metals like copper and aluminum are superconductive. So the part could be hot enough to burn your skin a long ways from the weld area. So just be cautious. Use gloves, pliers, clamps, or metalworking tongs to handle hot metal. Allow parts to cool before you handle them. And some material must be air-cooled slowly, and other common metals you can actually quench in water to room temperature without much risk. Just don't try that with cast iron or anything that's alloyed because it could crack.